Hello class, today what we're going to talk about is simplifying rational exponents. We're going to take some rational expressions that are kind of ugly and make them a little bit simpler, easier to deal with. All right? So to do that, we're going to use these properties here. So the first one we have is the product of powers. So what this is saying, we have two powers and we are going to multiply them together. Now this works if and only if your bases are the same. So we have a to the m times a to the n. Both of the bases are a. So all we have to do is take the exponents and add them up. All right? So 5 to the 1/2 times 5 to the 3/2. Well, they both have a base of 5. 1/2 plus 3/2. That's what we'll do there. And so 1/2 plus 3/2 is 2. So we have 5 squared, 25. All right. Power of a power. What this says is you have some power and you're raising it to a power. So something raised to an exponent, then you're taking all that, raising it to another exponent. And all you do here is you just multiply the exponents together. All right, so a to the m times n. So we have 3 to the 5/2 squared. We're going to take the 5/2. We're going to take the 2, multiply them together. 5/2 times 2 is 5. So this is 3 to the 5th, which is 243. Okay, the next one, power of a product. So here you have two numbers being multiplied together, and you're going to raise that product to the m power. And what you do is you can apply this exponent to both of the factors. So a to the m times b to the m. So in our example, we have 16 times 9 all being raised to the 1/2 power. Well, that's 16 to the 1/2 power times 9 to the 1/2 power. If you remember, the 1/2 exponent, that's the same thing as taking the square root. So this is the square root of 16 times the square root of 9. So 4 times 3, 12. This one, though, is honestly, it is more useful most of the time going from here to there. So starting with this and going back into this one. So here you'll notice, okay, our bases are different, but the exponents are the same. And since our exponents are the same, that same 1/2, we can take the 16 and the 9 and we can multiply them together. So 16 times 9, that's 144, and the square root of 144 is 12. And a lot of times that is more useful than taking it like this and going from here to there. All right. Still useful, and we still use it this way, but a lot of times we want to go the other way instead. Okay, negative exponents. What this does is it takes the reciprocal of the original. All right. So a to the negative m, that's the reciprocal of a to the m. So it's 1 over a to the m, provided, of course, that a is not 0, because then you'd be divided by 0. So what we have here is the 36 to the negative 1/2 power. That's 1 over 36 to the 1/2 power. So 1 over the square root of 36, which is 6. So 1 over 6. Another way to look at this, you can deal with the exponent first. So deal with the square root first. The square root of 36 is 6, and you've got 6 to the negative 1, which you take the reciprocal, and it's 1/6. So you can go either way with this. Zero exponent property. Anything raised to the 0 power equals 1, except for 0. 0 to the 0 power is undefined, but anything else, it doesn't matter what it is, raise it to the 0 power, and it equals 1, as long as you're not raising 0 to the 0. Okay, quotient of powers. What this is the opposite of product of powers. Here you are multiplying your bases, so you added the exponents. In this one, you're dividing your bases, which is the opposite of multiplication, and so you subtract your exponents, because that's the opposite of addition. Again, assuming that a is not 0, because then you'd be dividing by 0 down here, which you can't do. So here you have 4 to the 5/2 divided by 4 to the 1/2. Our bases are the same, so we can just subtract the exponents. 5/2 minus 1/2 is 2, and so that's 4 squared is 60. Power of a quotient. If you have two numbers, you're dividing them, then raising them to an exponent. You could raise them each to the exponent and then divide. So 27 divided by 64 to the 1/3, well, that's 27 to the 1/3 divided by 64 to the 1/3. So this is cube root. Cube root of 27 is 3. Cube root of 64 is 4. This one also, notice you can go from here 2 there. And a lot of times you'll want to. If your exponents are the same, you could just divide your bases and do it that way, which a lot of times is easier. Okay, so let's do some examples of this. We have these expressions here. We want to simplify them, get them a little bit easier to deal with. Now in A, we're multiplying 2 powers, and if you'll notice, they have the same base, 7, 7. Since the bases are the same, we are going to add the exponents. One thing that can help, if the bases are the same, you keep the base. If the exponents are the same, you keep the exponents. Whatever is the same, that's going to stay. It's the other part that's going to change. All right. So here, our bases are the same, so we are going to add those exponents up. So 1/4 plus 1/2, which is 3/4. We have 7 to the 3/4. Notice our bases were the same, so they stayed the same. Stayed 7. On this one, our bases are not the same. Our exponents are not the same. And so what we're going to do is we're going to take this power out here and we're going to apply it to both of these factors. So we're going to have 6 to the 1/2 squared and 4 to the 1/3 squared, like so. Now we have a power raised to a power, and same thing here. And when we have a power raised to a power, you multiply. So 1/2 times 2, 1/3 times 2. Right there they are. Well, 1/2 times 2 is 1, so 6 to the 1, which is just 6. And 1/3 times 2 is 2/3, so 4 to the 2/3. We end up with 6 times 4 to the 2/3 power. Okay, so number C. We're multiplying 2 powers together, and oh look, this time the exponents are the same, not the bases. And so we're going to keep that exponent at 5, and we're going to take the bases and multiply them together. So this is 4 times 3 raised to the 5th, and then raised to the negative 1/2. But we're going to multiply these bases together. 4 times 3, which is 12. So we have 12 to the 5th. Notice our exponents were the same, so the exponents stayed the same. But now we do have to deal with the stuff on the outside. So we have a power raised to a power, so we multiply those powers together. 5 times negative 1/5. Well, 5 times negative 1/5 is negative 1. So we have 12 to the negative 1. And that negative exponent, if you remember, it just takes the reciprocal. So 1 over 12. D. We are dividing. We don't see an exponent there, but remember there's always an exponent. If you do not see one, it is 1. So we have 5 to the 1 over 5 to the 1/3. Notice our bases are the same, and so we're going to keep that base, and we're going to subtract the exponents. So 5 to the 1 minus 3, or minus 1/3 rather, so 5 to the 2/3 power. Bases are the same here, same base here. Whatever is the same stays the same. All right. E. Bases are not the same, exponents are the same. So since our exponent is the same, it's that 1/3, we're going to keep that. And we're going to change these over here. So what we're going to do is we can take 42 divided by 6 raised to the 1/3 squared. Well, 42 over 6 is 7, so we have 7 to the 1/3. And we're going to take that and we're going to square it. So when you have a power to a power, you multiply the exponents, 1/3 times 2. So this is 7 to the 2/3. Okay. All right. And here we have some examples for you to do. So pause the video, simplify these expressions, and then come back, see how you did. All right, let's see how you did. And there are the answers. If you got these, great, you're done. If not, let's see what went wrong. Okay, so here is the work. Number 1, notice our bases are the same, and so we're just going to add the exponents. So 3/4 plus 1/2, which is 5/4. So we have 2 to the 5/4. Number 2, our bases are again the same, 3 and 3. So we're going to subtract the exponents. So I don't see 1, then it is 1. So we have 1 minus 1/4, which is 3/4. So we have 3 to the 3/4 power. On number 3, the bases are not the same, but the exponents are the same. So we can keep that 1.5 power, and we'll just divide the 20 divided by 5. So 20 divided by 5 raised to the 1/2 power cubed. Well, 20 over 5 is 4, and if you have a power raised to a power, you multiply them together. So 1/2 times 3, which is 3/2. Now here, if you remember that denominator, that means to take the nth root. So in this case, the square root. And the square root of 4 is 2, and 2 cubed is 8. So 8. All right, on number 4, bases are different. Our exponents are different. So we're going to have two different things here. And we're going to take them both and cube them. So we cube the first number, we cube the second number. So that means we've got a power raised to a power, so we're going to multiply. 1/3 times 3, 1/4 times 3. Well, 1/3 times 3 is 1, so this is 5 to the 1, which is just 5. And then we have 1/4 times 3, which is 3/4, so this is 7 to the 3/4. And you do leave it looking like that, 5 times 7 to the 3/4 power. And that is simplifying rational exponents. Hopefully that was helpful, and I will see you next time.